Okay, homework 16 is our first really new stuff. Isosceles and equilateral triangles that we covered in 15. It's new this year, but you've covered them before. But this is totally new. What we're going to be talking about in the next few sections is congruent triangles. So it's saying I have this triangle and this triangle, and I know like this side's the same as this side, this angle's the same as this angle, this side's the same as this side. Are these two triangles the same triangle? Can we assume that this third side is the same length as this third side? And there's 4 different things that work, or 4 different ways that you know that the triangles are the same. Those 4 ways are side angle side. And that's what we're going to talk about in this one. So that's what I just drew there. If you are given this information, then you automatically know that these 2 triangles are congruent. The next is side, 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 where if you're given all 3 of the sides are the same between 2 triangles, then you know they're the same triangle. They're congruent, same size and everything. Then we've got, oh no, I'm out of room here. That's okay. Side, angle, side, angle. So angle, side, angle. Angle, side, angle. You know those 2 triangles are the same. And the 4th option is angle, angle, side. So angle, angle, side. Angle, angle, side. You know those 2 triangles are congruent if you're given that information. If you're given side, side, angle, on 2 triangles, it's possible they're congruent, but they don't necessarily have to be congruent, because you could take this piece right here and move, so this full length, I can move it here, and it's going to be a really weird looking triangle, but, sorry, I did not draw that accurately. Okay, so we had this. Okay, I can take this side right here and move it like this. And then I've got congruence still. So side angle side does not work. And angle, angle, angle does not work. Because you can have a triangle this size and this size that have the same angles. Okay, if you half understood or even a quarter understood what I just said there, you are good to go. This is, even in person, this stuff is kind of iffy. It takes a long time to get the hang of it. So we're just going to brush through it, breeze through it. Sure. What you need to know for this specific chapter is this specific homework is we are talking about SAS. That stands for side, angle, side. And what we know is if you have 2 triangles where the side, the enclosed angle, and the side match a second triangle, or that second triangle between the first and second, then you know the triangles are the same size, have all the same lengths, all the same angles. Okay. This simply asks, what is the included angle between JK and KL? So with side angle side, it looks like this. The angle has to be included in between the 2 sides. This right here is not side angle side, because this angle isn't touching both of the sides that are marked. It's only touching one of the sides that's marked. So just because you have an angle and 2 sides, that doesn't guarantee it's side angle side. The angle has to be included in between the two sides you're given. So we are given side JK and side KL. The angle that's formed between those two angles, the included angle is this one, angle JKL. Also can be called angle LKJ. You just have to have the K in the middle. So let's see if one of those two options is there. JKL, yep, right there. Okay, name the included angle between PK and LK. That's going to be that angle right there. So that is angle PKL. Notice it uses the 3 letters there. You just have to get it in the right order. It could also be angle, so angle PKL or angle LKP. So let's find PKL right there. Okay, number 3 says decide whether enough information is given to prove that triangle ABD trying to draw this triangle over here. Is congruent to triangle CDB. From what I just drew there, it doesn't look congruent, does it? Okay, we are given a couple markings here. I'm going to mark a third thing. This is what's called the reflexive property. I usually call it the NODA property. What it says is a line is equal to itself. So this line right here, BD, is equal to this line right here, DB or BD. So BD is equal to BD. So we have a third thing marked now. In this green triangle, we have side, angle. And in this blue triangle, we have side, angle. That is not side angle, side. In order for it to be side, angle, side, it would have to look like this. Side, angle, side on both of them. So, no, we do not have side, angle, side. So, it's one of these two. No, there's only one pair of congruent sides. That's not true. There's 2 pairs of congruent sides. So then this one says no. The angles are not the included angles, and that is true. Included means it has to be in between the 2 lines given. So this is the correct answer. Okay, let's try that again. Decide whether enough information is given to say that LMN and NQP are congruent using side, angle, side. Well, let's look. The blue one has side, angle, side, where the angle is in between the 2 sides. The green one is side, angle, side. So yes, 2 pair of sides and the included angles are congruent. Notice with these markings, this is a double mark to indicate that this side matches this side, and single mark to indicate that this side matches this side. So not all 4 sides match each other, so you indicate that by using different tick mark or tick numbers. Okay, same thing here. This time we're given triangle YXZ. And, I should finish out that triangle, huh? triangle WXZ. Okay, what we know is this side, actually let's use different colors. This side matches this side. This angle is 90 degrees, so this angle has to be 90 degrees because the line is 180. 180 minus 90 leaves another 90. And then we can say, hey, ZX matches ZX by the no-dot property. So we can put 2 tick marks there. On my blue triangle, I have side, angle, side. On my green triangle, I have side, side, angle. Well, side, angle, side does not match side, side, angle. So this one's going to be a no. And one of the congruent angles is not included in the angle is the correct option there. This is not included. Included would mean in between this and this, so it would be that angle there. Okay, number 6. Hold tight. Yes. Okay, number 6, we've got QRV. Well, on that one, we have side, side, angle. So I'm just going to stop right there. That is not side, angle, side. So it's going to be a no. The congruent angle is not included in the angle. Included in between the 2 sides would be right here. It's right there. So it's this one. Number 7. EFH and GHF, we can mark this side equals itself. So we have side, angle, side in the green one. And in the pink one, we have side, angle, side. So it's yes. Let's check out these 2 options. 2 pairs of side and the included angles are congruent, or 2 pairs of sides and a pair of angles not included are congruent. Has to be the included angle that's congruent. So it's that one. Okay, number 8. It's got this arrow on it. That arrow means parallel lines. And if lines are parallel and cut by a transversal, so we have this line parallel to this line cut by this transversal, you know that the angle included in between the transversal, so this line, and the line is congruent to the other line and transversal angle. Okay, and I'm doing this one with you because I know there's a lot of new stuff in this homework. So it's okay if you don't understand all of it. That's fine. We're just letting you see it right now. We'll teach it more next year. So we also have this where by the reflexive property, a line equals itself. So on this triangle, we have side, side, angle. Whoop! We don't want side, side, angle, so I'm just going to stop right there. It's either one of those 2 options. The congruent angles are not included in the angles. True. This angle is not included. It would have to be right here to be included. So it's that one. Number 9 and 10. Okay. Oh, actually, 10's easy. Let's do number 10 and then we'll come back to number 9. Name the included angle between JL and JK. So obviously it's a single. You just need to name it. So decide what the name is for that one and then fill that in. Number 9 is what's called a 2-column proof. And with a 2-column proof, it just lays out all your thinking here. And I'm going to do this with you. Just understand part of it and you're good. The left side tells what markings you're using. The right side tells why you're allowed to do those markings. And our goal is to prove that triangle PQT is congruent to triangle RST by side angle side. Because this is the side angle side section. So all we need to do is say, well, we've got a side that matches, PT equals RT. We've got another side that matches, QT equals ST. We just need the included angle between the two sides on each triangle. So this angle has to match this angle. That's by vertical angles. Vertical angles is when they're across from each other. When two lines cross each other, the angles directly across from each other are vertical angles. Okay, so that will go right here. Side angle side goes right there. And then we just need to fill in the statements. We said this angle PTQ, has to be congruent to this angle, which is angle RTS. So let's see if we put that in the right order. PTQ, RTS. Oh, we did get it in the right order. So this has to go right there. And then what we're trying to prove is these two triangles are congruent. So that's what we're going to fill in right there. Those two triangles are congruent. So there's that to go right there. Sorry, that's